Okay. Number 13, 10.1. You throw a dart at the board shown. Your dart is equally likely to hit any point inside the square board. What is the probability that your dart lands in the yellow region? So I'm throwing my dart. It's going to end anywhere within this total square, right? Anywhere is equally likely. So if we look at what the probability of hitting inside like the yellow region, it's all going to be based on area, right? So if we can find the area of the yellow region and put it over the total area, we're good to go. But there's a little bit of a catch, right? Because we've got all these shapes in here, kind of a bummer, right? We've got this circly thing, a white square, two green triangles, bummer. So first things first though, we know the square, the total area, is just 18 squared, right? 18 times, so I'm going to write total area of the board is going to be 18 times 18. And I know I should know that one, but I don't. So 18 times 18, 324, of course. What else would it be? All right, that's the total area of the board, right? So now we have to look at that circle. Well, just the area of the yellow circle, not worrying about all this stuff on the inside, but just the area of the yellow circle. Let's do that. Area yellow circle. Well, the area of a circle is what? Pi r squared? All right, cool. So area of a circle is just pi r squared. Well, what's our radius? Well, this is a little tricky. But if we know this total length is 18, and it's a perfect square, so we have 18 over here, half of that gives us our radius, right? Yeah, just 18 divided by 2, so our radius would be 9. So this is just pi 9 squared. Pi 9 squared is, I'm just going to call it 81 pi for now. I'm not going to round that yet. We can get to that later. All right, cool. Now we know the total area and the area of the circle, but we still have to take care of all of this business. The white square, red circle, green triangles, all that. We've got to, because if it lands in one of those spots, it's not landing in the yellow region, right? So we have to take that off in some way. So let's do that. So let's just find the area of each one of these components and then subtract it from the area of the yellow circle, right? All right, let's do that. First, they tell us this measurement is 6 inches, right? Okay, well, it's a perfect square. This is a square, we know, because the circle fits inside it. It touches all sides. It's got to be a square. We don't really have to worry about the red circle area because it's completely within inside this white square, right? So, area of the white square. Let's do this. Area white square just equal to 6 times 6. 36. And I know I should have units on here, but I don't. Sue me. All right. Then we've got these triangles, right? Area green triangle. We'll just do it for one of them, and then we'll double it. That'll give us both. What's the area of a triangle? Well, it is 1/2 base times height. What's the base and height of this guy? All right, this is a little tricky. This guy, the white thing, we said that was a perfect square, right? The white square with the red circle inside it, that's a perfect square. Well, if it's a perfect square, then this, which we could call the base, would be 6 inches, right? Just a component of the square. All right, but how do we find the height, this value? Well, again, little tricky, have to be a little bit clever. We know that the total width of the outside square is 18 inches. We know this middle square is 6 inches. So if we subtract 6 from 18, we get 12 inches left. So that means between this side and this side, we have 12 inches to work with. Well, they're equally spaced on both sides. The symmetry of the picture tells us that, which means the height would be 6 inches, this distance, and then again, the base, this, would be 6 inches. So the area of this is just going to be 1/2 6 times 6, and that's going to be 18. But there's 2 of them, right? So we have to do double that. All right, 2 triangles. An area of 36. All right, I think we have all the information we need now. So I'm going to take the area of our yellow circle, which was 81 pi. Now I'm going to subtract the area of all the stuff inside it, which was 2 triangles, which we just calculated. And it was also the area of the white square, which was 36. All right. That gives me my total yellow area available. And now I'm going to put that over the total area, right? Which was the area of this blue square. That was everything, which we calculated to be 324. And that is going to give us some proportion, which is going to be the probability of having a dart land in the yellow. And I'll let you plug that into your calculator. No need for me to do that.